Momentum, a section of physics you probably know about as well as one of your school acquaintances. You know its name, but that's about it. Fortunately for you, that's what I'm here for, to inform you about momentum. Despite being a major player in Newton's laws, momentum actually wasn't thought up by Newton. It was actually thought up by a guy named Descartes. Descartes was born in France and grew up to be a renowned philosopher, mathematician, and, you guessed it, physicist. Basically, this guy saw that when someone caught something heavy or was moved by something heavy, they had to adjust, almost like they were springing back to counter the object that hit them. He really wanted a way to quantify this, so he messed around with some calculations for a while and eventually settled on P equals mv, also meaning momentum equals mass times velocity. But, a problem arose. See, when observing the collision of momentum, Descartes noticed that when two forces with equal momentum met each other in a collision, they'd come to a stop. But how could this be? If two forces met each other, shouldn't their force be increased as they were combined rather than decreased? Well, that's where this next guy comes in, Christian Huygens. He suggested that if two interacting forces were to make each other stop, one simply must be negative. For example, if one person is skating right and someone is skating left, one of them has to be negative to explain the neutralization of the force. And then after that comes Newton and his laws, which you definitely know about, but they pertain to this as they deal with momentum. Newton's first law is an object in motion will stay in motion unless an outside force is applied. An object will have momentum until something reduces that momentum, right? Newton's second law is a force is equal to its change in momentum. Ding, 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 there it is. And finally, his third law, with every action, there's an equal and opposite reaction. Well, if this train here has momentum and slams into this train with a force, the second train will react. Now, you're asking, Geo, why does this matter? How will I use this in the future? Well, you won't. Not in every field. But have you ever heard of a little occupation called being an astronaut? They need to know a whole bunch of physics stuff, one of which is momentum. I mean, they're in zero gravity. They gotta know that if they go forward, they're not gonna stop for a while until they hit something. Another field that requires knowledge about momentum is being a physicist. And lastly, if you go into the engineering field, you also need to know stuff about momentum. That sure is 3 occupations that require knowledge over momentum. That sounds like a lot of nerd stuff if you ask me. How will I, a totally not nerd, be able to use this knowledge? Well, have you heard of these little things called, I don't know, brakes? You need to know that when you press the brake pedal, you don't stop on a dime. This is because the brakes can't neutralize all the momentum of the car at once. It takes time. Alright, here comes the boring part. I will give you an example problem to show how this works. Let's say you're a 50 kilogram person and you're going 50 meters per second. You're a very fast runner. We take your mass of 50 kilograms and multiply it by your velocity of 50 meters per second. You have a momentum of 2,500 kilogram meters per second. Alright, now, if you're paying attention, and I did this right, you should know at least a little more about momentum.